Good morning, my YouTube viewers. It's Crystal here. I'm just here because I want to do another code review for you. But before I do the code review, I want to talk about some topics in Python on R, just to give you a little bit of brief insight before we go over the code. So the first thing we're going to talk about is bootstrapping. And so I've got this article here, Bootstrap Sampling Using Python. It says bootstrapping is a method that estimates the population characteristics by using repeated sampling of a representative sample. In this post, we will use Bootstrap in a real case scenario in which we will try to estimate the confidence interval of the population mean. So that's just a little bit about bootstrapping. And then what we're going to do is we're going to talk about the confidence interval. So you've got the formula here to calculate the confidence interval. And we'll look over here where it says what is the meaning of a confidence interval. A confidence interval is defined as the range of values that we observe in our sample and for which we expect to find the value that actually reflects the population. So that's your confidence interval. So now that we've covered bootstrapping and confidence interval, I got the question from this video right here. Statistics and probability full course. So that's where I got the question. And then so the course was written in R. So I've got the code in R right here. And we'll run it. Well, we'll go for the code first and then we'll run it. So what we did is dt equals read.csv, and then you've got a CSV file. So you can use the CSV file. I use the CSV file and it's still active. And it says attach dt, that's a code in R. st equals numeric. And here you're creating a function for I in 1 to 64, x equals sample, score, replace equals true. So score is a column in the data frame. The data frame itself has only 17 pieces, 17 rows. The data frame has 17 rows and one column. So really, it doesn't necessarily have to be a data frame. It could be a series, really, if that's what they wanted to do. And then STI equals mean X. So that's your function. And then you're going to make a histogram of ST, and then you're going to calculate the confidence intervals. And then and that was for 64. And then we did the same thing for exactly the same code using 1 to 1000. So we're going to run it. And so you've got your confidence intervals. And at 2.5% is 1.222, and 97.5% is 2.801. That was for the range of 1 to 64. And then when you have the range of 1 to 1000, confidence interval at 2.5% is 1.16667, and 97.5% is 2.7778. And come over here and we'll look at the histogram that's created. So this is the histogram for the 1 to 64, and this is the histogram that's created for 1 to 1000. And so basically what has happened is the more samples you have, the more the histogram looks like a normal distribution or a bell curve. So that's it for your R programming. So we're going to come over here into Python. And so what I did was I translated the code into Python. So what we did was we called it Bootstrapping Geography. So I used the exact same file that we used in R. And then we used bootstrapping. So bootstrap equals pd.dataframe mean rating, and then it says dt.sample. So you're going to sample it randomly, and we're going to sample it randomly 500 times, and replace equals true. And then we're going to sample randomly the score, and we're going to get the mean of that for I in range 0 to 64. And then we'll print the bootstrap, and then you got your bootstrap mean rating dot hist. We're going to make a histogram out of that, and then we're going to print the confidence intervals, print confidence interval of bootstrap mean rating dot quantile 0.025, comma bootstrap mean quantile 0.975, and then we're going to print mean of dt is the score. So that's probably something we could have done over here. We didn't do the mean of dt. So here's the score. Here's the first data frame that we've got. You can see it's not 17 rows, it's 18 rows. It's 18 rows of data. We sampled it 64 times. Here's the histogram that it created, and you've got your mean of dt is 1.9444, and confidence interval is 1.8 to 2.1104. And the problem is that I didn't know how many times they sampled it in R. And because I didn't know how many times they sampled it in R, the values aren't exactly the same. But I'm just able to show you how I did it. One thing that we can do is and I don't do very much programming in R. Usually, I've just started using R. So, we'll hope for the best. It says I got a warning. I'm going to try this. Try it again. No. Because I've just started using it. Okay, let's try that. A dollar sign. Let's try that. Try it again. So it worked. So the mean of the DT is 1.94444. So there you go, there's your mean. And so that is the same value that is in Python. And because I don't use R very much, I've just recently started using R. That's why I had to look up how to do it. Because, really that's something that's not very hard. But if you just started using R. Okay, now we go back to Python, and in this range we're going to use exactly the same code, but we're going to sample it 1,000 times. So you've got exactly the same code. You've got your score, you've got your 1,000 samples, and then we've got the histogram, and you can see that the histogram, the more times that you sample it, the more it looks like a normal distribution. So you can look at here. So you can see here at 64 samples, it didn't look very much like a normal distribution, but at 1,000 samples it did. And your confidence interval is 1.79195 and 2.086. And so our confidence interval has changed as well. So that's it for bootstrapping. I've covered everything that I can cover, and you've got the code in R and Python. And we talked a little bit about bootstrapping, and we've made some histograms so you can see the shape. So I think I'm going to go ahead and conclude this video. So I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you for watching my code review. I look forward to making more code reviews for you in the future.